Hello everyone, welcome back. Now let us discuss problem number 11 on page 495. This problem is also related to length contraction. Alright, so this is the figure and the problem says a record turntable of radius r, it is given radius r, rotates at angular velocity omega. The circumference is presumably Lorentz-contracted. Circumference is contracting by Lorentz transformation, but the radius is not. So radius is not contracting, but surface is not. Why it is not contracting? Because it is perpendicular to velocity. As we have discussed that the thing that is in the direction of that rotation, or you can say acceleration, in the direction of moving object moving, then that thing only contracts. So here omega is in the direction, so this circumference is contracting. What is the ratio of circumference to the diameter? So we need to calculate the ratio. So it is simple, as we know that circumference of circle, circumference, F-E-R-E-N-C, circumference of circle is 2 pi r. But the important concept is when this circumference is contracting, and for contraction we place a gamma here because of that length contraction. And the ratio is asking about the diameter also. Diameter of circle is 2r, but it is not contracting. Why? Because it is perpendicular to the velocity, angular velocity. That is why it is not contracting. As you know that from the previous question that we have discussed, that if velocity is in the direction and the part is also in the length part is also in the same direction, in this direction, then only it contracts. The perpendicular thing does not contract. So the ratio is pi by gamma. Simply c by d, if we do that becomes pi by gamma. Then he asks, this is the in terms of omega and r. He's asking the ratio in terms of omega and r. Simply now just apply the put the value of omega, that is 1 minus v square by c square, and we know that what is v. We all know that v is called the velocity. So the relation is omega r upon c. V is omega r upon c. So omega r upon c whole square. So this is the relation. Now he's asking according to the rules of ordinary geometry, it has to be pi. We know that because gamma would not be there due to the relativity. It came here. So what's going on? He's asking what is going on here. That why it is gamma downside. So it is just because we are studying relativity here, and in case of relativity, that objects moving in the direction of velocity, length moving in the direction of velocity, it contracts the length, and that is why the gamma is placed here. So this is going on here. So generally we do not see this kind of stuff, that circumference is contracting and radiuses or diameter is not contracting. This is a bit tricky problem, or you can say hypothetical, imaginary problem. So that's all for this video. The main concept is here is to introduce the length contractions, so you can get how length contraction is going on and why we are applying this rule. This is very important, that in the direction of the length, which is in the direction of velocity, contracted, but the perpendicular component does not contract, as we have seen in the previous video, that here this component does not contract, but this contracts. All right, so these points you need to remember, and you can easily solve the problems of length contraction. So that's all for this video. See you in next video. Bye bye.